we're going to talk about end behavior of polynomials because, Mr. Haas, this is kind of a tricky concept.
It is. It's really it's the first time we're asking them for some kind of value without really plugging it. You can't put anything in a calculator here. I mean, it's
Exactly
just
right.
thinking about what happens.
Exactly. So end behavior of polynomials, whenever we're talking about end behavior of a function, I like thinking about what's happening as you're leaving the paper.
Yeah.
As my
same
x
thing.
is getting bigger and bigger and bigger, and I'm substituting those bigger and bigger and bigger x values, what's happening to the outputs? What's happening to the y's? Am I getting really, really big y's? Am I getting small y's? Same thing when x is getting smaller and smaller, meaning like -10, -100, -1,000. What kind of outputs am I getting? Am I getting positive y's or negative y's? What's happening when you leave the page, right?
Sure. Yeah.
Who knows what's going on, right? Okay, so.
I get it. Very
Little
good.
modern dance.
Excellent.
I didn't work in
Yes.
jazz
No,
hands.
no, that's
All right.
okay.
So let's look at this polynomial. I'm not going to graph it right now. I'm not going to worry about finding the roots. I think we're all good about that. Let's just talk about the end behavior. We talk a lot about the controlling term, right? The controlling term is the guy who's in control, not always, but when I'm substituting in really, really huge x's or really, really huge negative x's, if you will. Does that make sense?
I get it.
So,
yeah. Sure. Like negative
glad
a
you know.
million or positive a million.
Right.
But you know, often we don't even have to like make the numbers that big.
Right.
Like for example, you could just think about sticking in what, like 10 or something? You
Yeah,
want to
let's
stick
just-
in 10? All right.
Let's look at 10. So if I'm putting in 10 to the 4th. So, wow, that's a big number. 10 to the 4th, that's 1, 2, 3, 4, right? Times 5. I'm already talking about, am I doing this right?
5.
50,000.
Yeah.
So even when my x is 10, my y is already around 50,000. Now you might be saying, but
That's
wait.
big. Oh, you're
It's big.
subtracting a lot
But
though.
I'm subtracting
Yeah.
stuff. But you know what? We don't even have to look at that. Because let's do it for this one time. This seems significant, but when I'm putting in really huge x's, that's not really going to take away much from my y value. 10 times 10 to the 3rd, well, that's just a measly little 10,000, right? Plus 23. So this 50,000 is going to be the powerful one. And think about it, that was just when I substituted in 10 for x. What if I substituted in 1,000,000 for x, right? So these little guys are very significant in terms of what the function looks like around the roots. But when I'm leaving the graph paper, when I'm leaving the page, this is the one that's in control. Am I making any sense?
I got it. Yeah, and actually, no matter how big the coefficient of that second term is, you could always pick a big enough x so
Right.
that that first controlling term is bigger.
Right.
Yeah. All right. So just ignore the rest of that
Just
stuff.
ignore the rest
Just
when
ignore
you're
it.
talking about end
Absolutely.
behavior. So then let's think about this. As my x is getting bigger and bigger and bigger, my y is going to be getting bigger and bigger. My end behavior is going to be going up. Does that make sense?
Sure, you're putting in, if you put in a positive x value, something positive to the 4th is positive.
Something positive.
Times 5 is positive.
Positive.
Great.
Okay, so now
Got
let's
it.
think about going in this direction. I'm getting infinitely small. Negative a 10 for my x. Negative 100. Negative 1,000,000. Negative Googleplex. Who, you know.
Big number.
So a negative number raised to the 4th, well, let's see, negative times a negative times a negative times a negative. That's going to give me something positive. And a positive number times a 5 is even more positive, right? So my function, I don't know what it's going to look like in here, but the end behavior is going to be up and up.
Got it.
All
Well,
right.
that's not too bad.
Yeah, it's not that bad. How about, give me another function, Mr. Haas.
Let's pick something negative in the beginning,
Oh,
like
okay.
negative 3x to the 9th. Something crazy. Minus or plus, or does it even matter what the rest of it
matter,
is?
right?
I don't. So let's just minus 2x to the 5th. You're just gonna work blah blah blah. Who cares what the
Plus
rest
blah
of it is?
blah blah, right?
Plus
because,
blah blah blah.
Because this is the guy who's the boss when I'm substituting in enormous x's or really, really negative x's, right? That is the controlling term. So let's just think about what happens. If I'm plugging in a 10, 100, a million, a billion to the ninth is something
Really big.
really big and
It's
really
big.
positive. But then I'm multiplying it by -3, so that means it's going to be really, really negative. My end behavior is going down as my x is getting bigger. Okay, let's think about what happens as my x is getting smaller. I'm approaching negative infinity. Think about plugging in a negative million. What's a negative million to the ninth?
Negative times
Negative times negative times
negative.
negative times negative times negative times negative times negative times negative times negative. What do you think, Mr. Haas?
Well, I think that's going to be negative.
I think it's going to be a
yeah,
negative.
You're going to have one negative left over if you think about it that way after pairing up all the twos of negatives. If
Exactly.
does that make any sense to you?
Yes,
Mr.
it
You know, I think
does.
you know what I'm saying.
So a negative million to the ninth is going to leave me with something really negative, but then I'm multiplying it by a +3, which means that that end behavior is going up. So again, who knows what's happening in here? That's where the blah, blah, blah comes in. But the controlling term tells us that the end behavior is going to look like this.
Got it. You don't know what the middle looks like. This
Right.
is just what happens at the end.
Exactly right.
Got it. Thanks.
You're welcome.
How you doing, Miss Stewart?
I'm fabulous.
I got another one of these beasts here. This time, it's in factored form.
Love that.
But make no mistake, I could just punch this bad boy into my calculator as it is, and you would get a lovely polynomial.
You would.
I mean, it's just factored out. I mean, I could multiply this guy out for sure, type it into the calculator, and get the exact same thing. I think sometimes students don't entirely realize that.
Right. That's an excellent point. That's just another way of expressing a function. You
Another
can
way. Nothing wrong
express
with
it as one term,
Sure.
a whole bunch of factors, or polynomial in all of its terms.
Anyway,
Lovely.
let's get back to
Glad
the
we
end
got that
behavior,
out of the way.
shall we?
Yes.
So somehow I have to find out the controlling term, right?
We do.
And you know, I could multiply it all out. I would maybe start at this end, you know, this times this, double distribute, right? That times that, that times that, that times that. But I happen to know that the first term, the controlling term, really comes from just multiplying the first guy of everybody. That's pretty nice, right?
Yeah. As
The
long as
second
it's the
term,
x, right.
yeah, as long as I'm multiplying the biggest term, one with the highest exponent of each little guy here, right? So
Let's do that.
basically I have, what I'm saying is I have an x times an x, which is an x squared. This guy really, it's x minus 4 squared, it's really x minus 4, x minus 4, right?
Yeah.
So this is x times x is x squared,
X squared.
another x cubed, another x,
X to the
the
fourth
fourth,
times the -2.
negative 2x to the fourth. Maybe, could I get the second term pretty easily? Oh no, that second term, yeah.
That would be a beast.
That'd be rough. That'd be
Yeah.
rough. I mean,
So
the
let's
second,
not.
Yeah. So blah 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 blah. Who cares?
Who cares? Because we're just talking about end behavior right now.
That's f of x. So again, I'm just going to look at the controlling term right there. If I put in, should I draw a little picture of it?
Sure.
If I put in a positive value for x, something positive to the fourth to any even power is positive times a negative gives me a negative.
So that's going down.
When I put in a negative value, negative to the fourth, or negative to any even power, gives me positive.
Something positive.
So basically what I'm saying is anything to an even power
It's going to be positive.
gives me positive.
Right.
Times a negative in front,
Negative.
negative.
So we're going down and down.
And again, some blah blah in the middle, not too concerned about it, but that's my end behavior, negative infinity in both directions.
Very nice.
Just one more. This happens to be one of my favorite functions, by the way.
You know what's amazing? I was just thinking that same thing.
Sure. It's a good one.
It is a good one.
So let's find the control.
An oldie
term,
but a
shall we?
goodie.
Shall we? So again, I'm not even going to write this up. This is really two of these guys, right? It's x minus 8 squared. So the first term, x times x, gives me x squared. X plus 4 squared, that's another x times x. So I've got x times x times x times x.
X to the fourth.
X to the fourth, thank you.
Times another
Times
x.
another x.
X to the fifth.
X to the fifth. Got the
And
6
we
there.
have the
Oh,
6, which is our k,
6,
right?
x to the fifth.
Good.
Blah, 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 blah,
Blah, blah, blah.
I like that. That's a good part. I like
Yeah.
that part. Okay. So I put in a positive value for x, positive to the fifth is positive,
Positive.
times a positive.
Positive. So my y is something really positive as
As I
the
go in
x
the
gets
positive x
bigger.
direction, goes up
My
to
y is
infinity.
getting more and more positive.
Stick in a negative, negative to the fifth stays negative, times a positive stays negative still.
Yeah.
So when I go in the negative x direction, put in a negative, I go down to negative infinity.
Beautiful.
Again, I don't exactly know what's happening in the middle, but you know, it actually could cross up to 5 times here.
Right.
But, something like that, I don't exactly know.
Right. Actually, if it's in
Yeah.
factored form, it's pretty easy to find the roots, but
It is.
yeah,
It is.
which is nice.
Sure.
Thank you. That was wonderful.